Okay, today we're going to learn another method for solving systems of equations. We've done graphing, and now we're going to do it algebraically through a method called substitution. Okay, you do exactly what it sounds like, and you just are substituting several times to get your ordered pair, where if you did graph the two equations, they would meet up. So step one, you're going to solve one of the equations from one of its variables. Okay, it's always easiest to solve for the variable that has a coefficient of 1 or -1, just so there's less dividing and less steps. Okay, and then you're going to substitute the expression from step 1 into the other equation and solve for the opposite variable. Step 3 is to substitute the value from step 2 into the equation from step 1 and solve. And then finally, you're going to substitute your solution into the original equations. That's your check step from last time. Okay, the words that can be kind of confusing, so we're going to look at some examples and I think it'll make sense. So the first one, we got to pick one variable to solve for, but we can see here that x is already by itself. Okay, and this is a trick I always teach my students. Just circle what that variable is equal to. Now, you could always have y first, it doesn't matter. And you can see y is circled, so I'm going to draw an arrow to the x in the opposite equation. Wherever you draw the arrow to is what you're going to substitute in. So now instead of writing x, I'm going to write what x is equal to, what I circled above. The reason this works is kind of common sense. If you think if anything's equal, it doesn't matter which you use. Okay, so the example I always give is my daughter can't have gluten, so I replace gluten flour with gluten-free flour. It's the same thing, same result, I'm just using a different type. Same idea here, instead of using x, I'm just using whatever x is equal to. You also know you substitute it right if you have one variable. If these are not the same variable, you did something wrong with your substitution. Now, I'm just going to distribute, and I'm going to solve it like a normal equation, combining like terms. Okay, so in doing that, I found that y is -2, but I'm not done yet. Picture those graphs we've done over the past few days, and you need an ordered pair. To solve for y, or for x, I'm sorry, I'm going to plug into this top equation because it's already set up, so x is alone, so it's a lot less work. Technically, you could plug it into either equation, but if x is already isolated, it's going to be less work. And your answer is an ordered pair. Check step is easy. Plug 6 in for x, -2 in for y. So -2 times -2 is +4, plus 2 is 6, which works. Here we have 3 times 6 is 18, plus -2 is 16. So since it worked in both equations, we know we got it right. So I'm going to walk you through what I did here now that you can see it. I got one variable by itself, circled what it's equal to, drew a line to the opposite variable in the other equation, and replaced that variable. Now I check to see that I have the same variable in both parts, and I solve my normal equation. I take that answer and I'm going to plug it back into the variable I got by itself to begin with, and write it as an ordered pair. Okay? I'm going to do another one. Okay, this one, if you look carefully, you can see y is already isolated here. So I'm going to circle what it's equal to. X is in the circle, so I draw a line to the y. And I'm going to replace y with the equivalent expression, 6x plus 5. I'm going to stop there and self-check that I have the same variable. And I use the opposite equation, so we're good to go. Now I'm going to distribute combine like terms. Solve like normal. Okay, not done yet. I need to solve for my y. I'm going to come up here. Y is already by itself here. And I'm going to plug -1 in for x to solve. And in this case, I got -1 for both. That won't always happen. Let's double check. So I have 5 times -1 is -5. 4 times -1 is -4. So -5 minus -4. -5 plus 4 is -1. 6 times -1 is -6. Plus 5 is -1. So it worked. Okay, we're going to do one more of these together. Now, this time we're going to have to solve for one of the variables first. It doesn't matter if you solve for x or y first. I'm going to look to see if one of them would be easier. So this y has a coefficient of 1 and this x has a coefficient of 1. Whichever one you choose, personally I would choose one of these so you don't end up with fractions. It'll make your life a lot easier. I'm going to go ahead and solve for this y just because it's on the top here. The only difference if you solve for x first is the order of the variables you end up with your answers. Okay, so I'm going to circle what y is equal to. Draw a line. Since x is circled, I draw a line to the y and replace it. Double check that I have the same variable written. And then I'm going to go ahead and distribute. Hopefully you can read despite my pen. Alright, so I have x is -1. Now I'm going to come back up here. I always recommend rewriting the whole expression that your other variable is equal to avoid careless errors. So I got -1/3. Technically, to plug in to solve for y, once you have your x, you could plug into either one of the original equations too. Okay, so on your note sheet, your next job will be to do 4 and 5 as you tries. And we're going to look at 6 together on the back. This one, y is already solved for, so I'm going to circle it, draw my arrow, and replace. Making sure I'm down to one variable. 2 times 1/2 is 1. Now, some of you may be able to see the issue here. X minus x is 0. Those are going to cancel. Now I'm left with -4 equals -4, which is a true statement. So just like our other equations, this means I have an infinite number of solutions. We'll talk about this more in class next time, but this is the exact same as graphing. If I graphed each of these lines, they would be the same line. On the other ones, if I graphed them, they would intersect at the ordered pair. Okay? Number 7 is your last you try. If you have any questions, make sure you're coming in for help.